Okay, assalamualaikum and good day everyone. So I hope you guys in a good health and ready for the next part of this chapter 5. So for this lecture, we are going to focus, this last two lecture, we are going to focus on these two subtopic, which is exponential and logarithmic functions. So what we learn in lecture 1, lecture 2, lecture 3, we will apply in exponential and logarithmic function. Okay, so for this lesson, we are going to find, at the end of the lesson, students should be able to find the relationship of exponential and logarithmic function by algebraic and graphical approach, and then state the domain and range of exponential and logarithmic function. Okay, so we also have to know how to find, how to sketch the graph lah, because we want to find the relationship between these two functions by using the graphical approach. Okay, exponential function. So we've learned about exponential equation, expression. Now we want to learn about exponential function. So exponential function is a function of the form fx equal to a to the power of x, where a is a value more than 0 and a must not equal to 1. The basic exponential function, so we have fx equal to a to the power of x, where a is more than 1. Let's say 2, 3, 4, and so on. And then the second one is fx equal to a to the power of x, where a is in between 0 and 1. So it will be a fraction. So let's say for a, fx equal to a to the power of x, where x is a real number and a must be more than 1. So the domain is always negative infinity to infinity. And then the basic properties, fx is always more than 0 for x is a real number. And then when x equal to 0, fx is equal to a to the power of 0, which is equal to 1. So it will have an y-intercept at 1. And when x approach to infinity, means that it's going to the right. The fx will be going to positive infinity, means that it's going up. And then when x is approaching to negative infinity, okay, if approach to negative infinity, means that the x going to the left, the fx, the value of y, will approach to 0, approaching to 0. Okay, so the 0, the value of y is approaching to 0. This is when y equal to 0, left and 0. So the range, after we sketch the graph, we can see that the range is starting from 0 to infinity, where 0 must not included. Okay, now let's see the graph, how the graph looks like. Okay, so this is our graph with x and y axis, and then we will have intercept at y equal to 1. So this is our graph. When x approach to infinity, it's going to the right. The value of y also approach to infinity, going up there. So the graph should be belong around here lah. And then when x approach to negative infinity, means that it's going to the left. The value of y is approaching to 0. Okay, but it must not pass through the x-axis when y equal to 0. Okay, so if a to the power of x equal to 0, there is no such thing. Okay, it must not cross 0, y equal to 0. Okay, so this is our graph of a to the power of x, an exponential graph where a is more than 1. And then for when a is in between 0 and 1, so the domain is also negative infinity to infinity. It's always true for exponential function. And the basic properties for fx, always more than 0. When x equal to 0, y equal to 0. when x approach to infinity, fx is approaching to 0. When x approach to negative infinity, the fx approach to infinity. So it will be opposite. Okay, so what is this value a in between 0 and 1? So let's say 1/2. So 1/2 to the power of x, it also can be written as 2 to the power of negative x. Why? This 1/2, if we written it in a basic form by using the rule of indices, is equivalent to 2 to the power of negative 1 to the power of x. So it's actually to the power of a negative. So another method to say this is when fx to the power of a to the power of fx, or gx, where this gx is a negative of x. Okay, the value will be opposite of the part A function. Okay, so it will be the opposite values. So if we see the graph, the range is still 0 to infinity, but 0 must not included. But the graph, so it will be when x approach to infinity, it will approach to 0, the y equal to 0. And then when x approach to negative infinity, the y is approaching to infinity. So it will be reflecting on the y-axis here. Okay, previously for a more than 1, the graph will be look like this, right? So it's actually reflecting on the y-axis. Okay, so this is the difference between the two types of function. Okay, so did you remember yet? Okay, there are two types of function. It's either negative x or positive x, the power is. So it's depend on the power. It's depend on the base or the power. So either one lah. Okay. Example 1. So sketch the graph of the following function and state the domain and range. So let's see how do we sketch the graph for the exponential function. So for question A, y equal to e to the power x. So what we have to do first is to determine the domain. So always remember, for exponential function, the domain is always negative infinity to infinity. And then we find the intercept, the y-intercept when x equal to 0. So y equal to e to the power of 0, which is equal to 1. This is equivalent to e to the power of 0, which is equal to 1. So it will be 0, 1. And then, yes, determine the value of y when x approached the endpoints of the domain. So what is the endpoint of the domain? Negative infinity and infinity. So do the same thing as the basic properties of exponential function, means that when x approach to negative infinity, y approach to, so e to the power of, I always use this, e to the power of, what is our x? Negative infinity. So if e to the power of negative infinity, you can try by using your calculator, e to the power of negative 1,000, 10,000, negative 100,000. So you will get a really small value. Let's say to the power of 10 negative something. So it's 0.00000, which is, it's really close to 0. Okay, so you can remember e to the power of negative infinity is approaching to 0. Almost the same as 0. And then when x approach to infinity, so means that e to the power of infinity, you can try by using your calculator, e to the power of 10,000, you get a really big number, which is the number can be approaching to infinity. We don't know how big the number is. Okay, so for x, the negative infinity is to the left, the positive infinity is to the right. But for y, this one is approach to 0. The approach to infinity means that it's going up. So to sketch the graph, so we put these 2 points. So what is the x coordinate? Negative infinity. Y coordinate is 0. And then here the x coordinate is infinity, the y coordinate also infinity. So on the graph, so we plot these 2 points. We assume the negative infinity will be on the left side for x. So we have these 2 points. 0, 1 is the intercept, and then these 2 points, negative infinity 0, will be the left side of x and approaching to 0 of y, and then infinity is the right side of x and the upper side of y, right? So we just connect these 3 points into the basic shape of the exponential graph, which is like this. It always like this, it must pass through the intercepts. So this is our graph for each of x, and then from the graph we can determine the range. So what is the range? The range here, we can see the value of y is starting from here, which is start from the domain is negative infinity to infinity, we know already, and the range is starting from 0 and going up there, so it's going to infinity, but the 0 is not included because it's just approaching, so it should be a round bracket here. Always a round bracket for this exponential range. Okay, so let's move on for question B. So y to the power of negative x, or it's equivalent to 1 over e to the power of x. So 1 over e is a value that is in between 1 and 0. Or another way to recognize this is the power of x is negative. We have negative x here. Okay, so how to find the domain range and sketch the graph? So first, determine the domain. It always negative infinity to infinity for exponential, and then the next step is to find the y-intercept. So when x equal to 0, y equal to e to the power of negative 0, which is e to the power of 0 equal to 1. So we have intercept at 0, 1. And then the next one is to determine the value of y when x approach to the endpoint of the domain. Okay, so what is the endpoint? Negative infinity and infinity. So when x approach to negative infinity, y will approach to e to the power of negative x. What is x? Negative infinity. Which is, this is e to the power of positive infinity. So e to the power of infinity, so it will be a really big value. Okay, that's why y will approach to infinity. And then when x approach to infinity, so y will approach to e to the power of negative of infinity. Why? It's negative of x. So that's why we have approach to 0. So we have these 2 points to connect. So use this point we have to draw the graph. So we have intercept at 0, 1. And then we have points negative infinity. Left side of x is going to infinity, so it's up, left and up, and then for infinity it will be approaching to 0, so infinity to the right and 0. So we just have to connect these 3 points to guide it as the shape of the exponential function. So it will be like this. So this is our graph. And then now from the graph we can determine the domain. Domain we know already, always negative infinity to infinity. And range, we can see that it's the value of y is starting from 0 up to infinity, but 0 must not included. It's just approach to 0. Okay, so that's why it's 0 to infinity. So that's for B, example B. Okay, so for example C, y equal to e to the power of x plus 2. So we repeat the same step. So we determine the domain first. So always negative infinity to infinity for exponential. And then find the intercept. So when x equal to 0, y equal to e to the power of 0 plus 2. right? E to the power of 0 plus 2 is e to the power of 2. So we have 0 e to the power of 2 as the intercept. And then determine the value of y when x approach the endpoint of the domain. So when x approach to negative infinity, y approach to e to the power of negative infinity plus 2, which is negative 10,000 plus 2, it will be negative 99998, which is really big too. So it will be almost e to the power of negative infinity. We can assume that it's almost e to the power of negative infinity, which is this value is approaching to 0. And then when x approach to infinity, so y will approach to e to the power of infinity plus 2, a really big number, plus 2, still a big number. Okay, so that's why e to the power of infinity. So e to the power of infinity is actually approaching to infinity. So we have these 2 points. So we sketch the graph by plotting these 3 points. So we have 0 e to the power of 2, and then we have negative infinity approaching to 0. So it will be left and 0, and another one is infinity and infinity, so right and up. So connect these to 3 points, so we have the shape. So this 3 points is just the guide, okay? It's not exact value because we don't know what is infinity. We use it as the guide to sketch the graph. Okay, so we can just delete or erase back these 3 points. And now to determine the domain and range, so with domain we always know negative infinity to infinity, but for range, so from the graph we can see it's starting from 0 up to infinity. So 0 must not included, so it should be a round bracket. Okay, so we have done this for 3 times already. I think you know how to do for question D, right? So we do it fastly for question D. Okay, it's a bit different because now we have 1 minus e to the power of x. So don't panic. What we need to do is just the same step as usual. So first, determine the domain and range. It's always negative infinity to infinity. The next step is, yes, y-intercept. So when x equal to 0, y equal to 1 minus e to the power of 0. Okay. So, if we substitute the value, it's equivalent to 1 minus e to the power of 0 multiplied by 0. 2 multiplied 0 is 0. E to the power of 0 is 1. So, 1 minus 1 is 0. That's why we have 0 as the answer. So, the point here is 0, 0. So, it will intercept at 0, 0. Now, for the next step is determine the value of y when x approach to the endpoint of domain. So we don't have to write down this everything here. You can just show the work. So when x approach to negative infinity, y approach to 1 minus e to the power of 2 of negative infinity. So this is 2 to the power of negative infinity is negative infinity. E to the power of negative infinity is 0. So 1 minus 0 is 1. So that's why y will approach to 1. And then when x approach to infinity, the y will approach to, so we calculate or write down first 1 minus e to the power of 2 of infinity. So e to the power of 2 infinity is the same as e to the power of infinity. Double of infinity is infinity. So e to the power of infinity is infinity. So 1 minus infinity, 1 minus really big number. So this big number is a negative number. So it will be, yes, negative infinity. Okay, so if you don't understand, you use one value. So 1 minus negative 1 million. So it will be a negative number, right? So it will be a negative infinity. So we have these 3 points already. We sketch the plot and sketch the graph. Okay, we assume, so when we have 3 points, the first one is the intercept at 0, 0. So point at 0, 0. Oh, now the value is approach to what? So when x approach to negative infinity means that it's going to the left, the y is approaching to 1. So we have to draw the dashed line of 1. Okay, so draw the dashed line of 1 first, and then we can either plot bottom below of 1 or upper of 1. So it depends on the second point. Okay, for the second point here, we have infinity, x infinity, y is negative. So x to the right, so y is going to negative infinity. Negative infinity is bottom. So the point we should plot is here. Okay, so it's on the bottom, means that it cannot pass through the 1 because the line here, it either going up or going down. So if it's going up, so we take this one. If it's going down, we take this one. So because the plotted dot is at the bottom, so we should take the bottom one. So we delete the upper one. Now we can connect these 3 points to get the graph. So we have this graph for our function fx equal to 1 minus e to the power of 2x. Okay, now from the graph we can see the domain and the range. So what is the range? The value of y on the plotted graph is starting from the bottom, right? So it should be from negative infinity up to, it just stop approaching to when y equal to 1. Right, so it's coming from negative infinity up to 1 where 1 is not included. Okay, so another method to determine the range. Okay, first of all, you can see the coefficient of exponent itself and then the addition value here. So this negative of exponent, it will reflect on the x-axis. So usually we have this type of graph or this graph, right? So because we have negative, it will reflect. So we have a positive x here. So it should be which graph? It should be this type of graph, right? And then because we have negative in front of exponential here, so it should reflect on x-axis. And then that's why we have this type of graph, and it should be like this because the x-axis will be the asymptote, but because we have plus 1 here, additional plus 1 here, that's why the graph will be shifted. Okay, the graph will be shifted. The y equal to 1 will be the asymptote. So the asymptote, it will be the division, whether it's upper value of 1 or bottom of 1. Okay, it depends on the sign. So because it's a negative of exponential here, so it will be bottom value of 1. Okay, for that method you have to remember. So that's why we do this step, because we just have to follow the value, the calculation, so you don't confuse by remembering all the type of function. Okay, you just have to follow this step, so you don't have to remember. Just connect the 3 points, then you have the graph. Okay, so let's continue. Example 2. Sketch the graph of the following functions and state their domain and range. Okay, so first of all, let's analyze first this type of function. So we have 4 to the power of x, so it's just like e to the power of x. Okay, it's really simple, positive x and positive exponential, positive base. And then for question B, we have 4 to the power of x, which is the same as a, but we have additional plus 1. So what will change? The y-intercept will change and the range also will be changed. Okay, so this value plus 1 will shift the graph by 1, positive 1. It's going up by 1. Okay, let's see the answer later. And then for question C, it's 2 to the power of x. Okay, so base, the difference is base, but it's still positive, but minus 3. So this minus 3 is actually will be shifting by negative 3. So the graph will be, if it's positive, it will be going down by 3. And then the last one, this is just Analyte Analysis. Yeah? So the last one here, we have negative of 3x. So it's a 3x. Yes, we know 3x is a positive going up. But because it's negative, it will reflect by x-axis. It's going down. But it will be shifted by 1. So like this. Okay? So shifted by 1 means that the asymptote will be at y equal to 1. Okay? So this is how we analyze the basic shape of the graph. So this is, we can just directly sketch the graph. I know already how the graph look like, but for you guys, the beginner, we have to do step by step lah. Okay, let's see for question A. Determine the domain, determine y-intercept, determine the value of y when x approaches to end of point of the domain. This is the step that you have to follow lah for your level. And lastly, sketch the graph. So now for fx equal to 4 to the power of x, determine the domain negative infinity to infinity, find the y-intercept. So when x equal to 0, y equal to 4 to the power of 0, which is equal to 1, always 1. And then the value of y when x approaches to the domain, endpoint of the domain. So when x approaches to negative infinity, y approaches to 4 to the power of infinity, negative infinity, which is 0. When x approaches to infinity, y approaches to 4 to the power of infinity, which is equal to infinity. So we have this point. So the graph basically will look like the same as exponential to the power of x. Okay, so what is the difference? Okay, we have the intercept at 0, 1, and then negative infinity approach to 0, infinity approach to infinity. So we have this graph. So what is the difference between e to the power of x and 4 to the power of x? So we didn't see it here, but actually it will be difference on the curve of the graph. So it might be like this, okay. So the slope of the graph will be different. So we cannot see in this sketching this type of difference. We can see only by plotting all the values. Maybe you can use the online graphing method. Okay, so we can see the difference on the slope of the exponential graph. So we cannot see it here, but we can see in another method lah. So you don't have to worry about that. Now, for the range. So we can see that the value of y starting from 0 to infinity. Okay. So we've done with question A. Continue with question B. So for fx equal to 4x plus 1, always starting with the domain, it always starting from negative infinity to infinity. And then determine the y-intercept when x equal to 0, y equal to 4 to the power of 0 plus 1. So 4 to the power of 0 is equal to 1. So 1 plus 1 is equal to 2. So now the intercept is at y equal to 2, not 1. And then we find the value of x when x approach to value of y when x approach to endpoint of the domain. So when x approach to negative infinity, so we have y approach to 4 to the power of negative infinity plus 1. So 4 to the power of negative infinity, any base to the power of negative infinity is always equal to 0. Any base to the power of infinity will equal to infinity. So you have to remember this. So 4 to the power of negative infinity is approaching to 0. So 0 plus 1 is 1. So this y will approach to 1 when x approach to negative infinity. And then when x approach to infinity, y will approach to 4 to the power of infinity plus 1. This 4 to the power of infinity is infinity. Infinity plus 1 is infinity. So that's why it's approach to infinity. So now we have 2 points. So the next step is to sketch the graph. So we have 3 points. Plot the 3 points 0, 2, and then approach to negative infinity to 1. So this is on approaching side. So if it's on approaching side, we have to draw the dash line for it. So y equal to 1, we have to draw the line y equal to 1 here. And then the value negative infinity is going to the left, it's approach to 1. So it's either on bottom side or upper side or bottom side. But now we can conclude it by looking at the third point, which is when x approach to infinity, the y is approach to infinity. So it's going up. So the point should be upper side of the y equal to 1. So now we have the 3 points. You just have to connect the 3 points. So this is our graph. So now to determine the domain always negative infinity to infinity, and the range, we can see that it will approach to 1 from 1 to infinity. Okay, approach to 1 and infinity. So it should be open bracket for 1 to infinity. Okay, so this value, these properties you have to remember lah. Okay, now for question C. Okay, now let's see at question C. So it's actually fx equal to 2 to the power of negative x. So I didn't notice the negative here, minus 3. So it will be different from question B. So let's see it together. So when x, what is the domain first? So it always negative infinity to infinity. And then when x equal to 0, the y-intercept. So y equal to 2 to the power of negative 0 minus 3. So negative 0 is 0, 2 to the power of 0 is equal to 1. So 1 minus 3 is equal to, yes, negative 2. So we have a point of 0, negative 2. And then determine the value of y when x approaches the endpoint of the domain. So when x approaches to negative infinity, y approach to 2 to the power of negative infinity, because negative x minus 3. So this will be positive infinity. So this is infinity. Infinity minus 3 will be, yes, infinity is really big, right? So it will be a really big infinity, yeah. And then when x approach to infinity, y will approach to 2 to the power of negative of x, negative of infinity minus 3. So this is 0. So 0 minus 3 is equal to negative 3, means that the y will approach to negative 3. So we have these 3 points, and then plot the points 0, negative 2, so it's bottom below the x-axis, negative 2, and then negative infinity, infinity, so to the left and up, right? Yeah, and then the last one is infinity to negative 3. So we have to sketch, we have to draw the line, dash line of y equal to negative 3. Okay, so the points infinity to negative 3 should be up of the line, because we have negative infinity, infinity bahagian atas. Okay, so it should be on the upper side of the line. So that's why we have this dot. Now just connect the 3 points, so we have the graph. Okay, now we have the graph already, we have the domain, and then now what is the range? So the graph plotted on the side of when y is more than negative 3. This is y negative 3, right? So the range is starting from negative 3 up to infinity, open bracket. Okay, so this is for C. For fx equal to 2 to the power of negative x minus 3. So let's see for question D. Y equal to negative of 3x plus 1, domain always negative infinity to infinity, and y-intercept when x equal to 0, y equal to negative 3 to the power of 0 plus 1. So this is equal to 1. So negative 1 plus 1 is 0. And then we have 0, 0 lah. When x approach to negative infinity, y will approach to negative 3 to the power of negative infinity plus 1. So this is 0. So it will be approaching to 1. And then when x approach to infinity, will be 3, negative 3 of infinity plus 1. So this is infinity. So negative infinity plus 1 will be negative infinity. So that's why we have these 2 points, which is negative infinity 1 and infinity, negative infinity. So plot the 3 points. We have 0, 0, and then negative infinity to 1. So we have to draw the line y equal to 1, the dashed line y equal to 1, and then plot the point negative infinity 1 either side first, and then the second one is when x approach to infinity to the right, the y is approach to negative, so bottom. So we have another point here. So we know that the point on the top shouldn't cross the y equal to 1, so it will be bottom below the y equal to 1 line. So connect 3 points, so we have this graph. So now determine the domain and range. So domain we know always negative infinity to infinity, but for range we can see that the value of y is starting from bottom here, which is negative infinity going up to 1 only. So both are open bracket. Okay, so this is our graph. So we can see many types of graph we have drawn. So it's depend on the type of exponential. Okay. Okay, now let's continue with logarithmic function. So it's starting from the logarithm equation, and then now it's a function. So a logarithmic function is defined as oh my god, fx equal to log to the base b of x, where x is an element of real number and b is a positive value. It's more than 0 and b must not equal to 1. Okay, now basic logarithmic function. So let's say fx equal to log to the base of b of x, where x is more than 0, b is more than 0, where b must not equal to 1. And then another one is when b is in between 0 and 1. This is the same as exponential. This value of b, the base. For exponential, the base a shouldn't be will be more than 0 and in between 0 and 1. For logarithmic, the base here is b, so this b should be one type is b more than 0, another type is b in between 0 and 1. Notice that log to the base b of 1 is always equal to 0, and x is more than 0 because log b of a negative number is not defined. Okay, that's why we cannot have b equal to 1, because 1 to get 1 will be 1. Okay, so b must be more than 0 or in between 0 and 1. And our x always more than 0. Okay, if our x is always more than 0, means that the domain, this is talking about our domain. So our domain must start from 0 up to infinity. So it can be not only x, any function here. Let's say if we have x plus 1, means that x plus 1 should be more than 0. So that means the domain should be x more than negative 1. Okay, so everything here should be more than 0 lah. We cannot have negative value. Okay, let's see some example. For fx equal to log to the base of b of x, where b is more than 0. Okay, so the domain is 0 to infinity because this x should be more than 0. So it's starting from 0, where 0 must not included. And then the basic properties, when x equal to 1, fx equal to, so now we are finding the x intercept. Okay, x intercept. So it will be opposite from the exponential. When y equal to 0, what is x? Okay, so we have log to the base b of x equal to 0. So x is equal to b to the power of 0, which is x equal to 1. Any base to the power of 0 is equal to 1. That's why we have 1, 0. Okay, because it's an x-intercept, not y-intercept. Okay, and then the next one is when x approach to 0. What is 0? The endpoint of the domain. Y will approach to log to the base b of 0. So any base of 0, we can assume it approaching to negative infinity. And then when x approach to infinity, log to the base b of infinity always infinity. So y is approaching to infinity. So the range is this value y. So negative infinity to infinity. So if we notice that the range is always from negative infinity to infinity. Okay, so this is the graph. So because we have intercept at 1, the x-intercept is at 1, and then when x approach to 0, it's going to negative infinity. So it's here. And then when x approach to infinity, y approach to infinity. So we have this graph. So for b, so this is for b in between 0 and 1, which is a fraction. Okay. So a fraction, a domain from 0 to infinity, because x is more than 0, always more than 0. The basic property when x equal to 1, y equal to 0. So we have to find the x-intercept. And then when x approach to 0, the endpoint here, so y will approach to infinity. And then when x approach to infinity, y approach to negative infinity. So because this b is a fraction, okay, so now range always from negative infinity to infinity. So the graph, we plot these 3 points. So intercept at 1, x-intercept at 1. When x approach to 0, y approach to infinity. When x approach to infinity, y approach to negative infinity. So we have the graph. Okay, let's see example, real example. Example 3, sketch the graph of the following function and state the domain and range. So we have natural log of x, means that log to the base of ex. And then natural log to the base of e of 2x minus 1. And then log to the base of 3, 1 minus 4x, and y equal to negative log to the base of 10 of 2x plus 1. If we didn't have any base here, means that we are using common log. So common log is log to the base of 10. So the solution, we should follow this step first, is to find the domain. Determine the domain. Remember, any function inside the log is always more than 0. And then determine the x-intercept, means that when y equal to 0, x is equal to what? And then find the value of y when x approach to the endpoint of the domain. Okay? And then sketch the graph. So for question A, y equal to natural log of x. So natural log of x, or log to the base e of x. So determine the domain. So this x must always more than 0. So that's why the domain is from 0 to infinity. So in between 0 to infinity, 0 is not included. Okay, now we can find the intercept, the x-intercept when y equal to 0. So natural log x is equal to 0. So x is equal to e to the power of 0. Right? E to the power of 0 is equal to 1. That's why we have 0.10. Okay? And then the next step is to find the value of y when x approach to the endpoint of the domain. So what is the endpoint of the domain? 0 and infinity. So when x approach to 0, y approach to natural log of 0. So log to the base anything 0, it will be equal to negative infinity. That's why this y is approaching to negative infinity. And then for x approach to infinity, y will approach to natural log of infinity. So natural log infinity, log to the base of e infinity is always equal to infinity. Okay, so the basic formula here is log to the base of b of 0 is equal to negative infinity. Log to the base of b of infinity is equal to infinity. So you just have to remember this, the same as a to the power of negative infinity and a to the power of infinity. So now we have 2 points from this. Now what you need to do is just sketch the graph by plotting these 3 points. So we have 0.10, and then when approach to 0, it's going negative infinity, so it's going down. So it will be here or here. And then infinity, infinity, so it's going to the right and up. Means that we take the value of this one, 0, infinity, on the right side of 0. Okay. So we have this 3 point. We just have to connect the 3 point. And then we have the graph. Okay. So this is our graph. So now what we need to do, the last thing we need to do, we have the domain already. We have the range. So what is range? The value of y here is starting from negative infinity up to infinity. So it's everything lah, real number. Okay, so we've done question A. If you notice that the step is almost the same as exponential. Okay, we have to determine the domain and then find the intercept and then find the endpoint, the limit, the value of y at endpoints. And then sketch the graph. Okay, so for question B, y equal to natural log of 2x minus 1. So remember that I said earlier, everything inside the log should be more than 0. So 2x minus 1 more than 0, so x should be more than 1 over 2. So the domain is starting from 1 over 2 to infinity, not included 1 over 2 lah. Okay, and then when to find the x-intercept when y equal to 0, what we have is natural log of 2x minus 1 equal to 0. So 2x minus 1 is equal to exponent to the power of 0, which is equal to 1. Right? So 2x is equal to 1 plus 1 is 2. So x is equal to 1. So you have to find this value x. Not just directly, oh, it's equal to 1. No. You have to find it. So 2x minus 1 is equal to e to the power of 0, which is 1. So x is equal to 1. So we have a point of 1, 0. Okay, next. Determine the value of y when x approach to the endpoint of the domain. So when it's approach to 1 over 2, so y approach to, so 1 over 2 natural log of 2 multiply 1 over 2 minus 1. So this is equal to 1. 1 minus 1 is equal to 0. So natural log of 0 is negative infinity. When x approach to infinity, y approach to natural log of 2 multiplied by infinity minus 1. So 2 infinity is infinity. Infinity minus 1 is infinity. So natural log of infinity is equal to infinity. Okay, so remember the formula earlier, properties earlier. So we have these 2 points. So now to sketch the graph, we just have to plot these 3 points. It will approach to, the first one is 1, 1, 0. Oh, first we sketch this graph 1 over 2. 1 over 2, not graph, the line 1 over 2, because our domain is starting from 1 over 2. So this will be the asymptote. Asymptote, so draw the dash line. And then x will cross at 1, this point 1, 0. And then when x approach to 1 over 2, so it's going to the graph here. Y is approach to negative infinity. So it's going down. So the point will be the bottom. And then when x going to the right, infinity, so y also going to up infinity. So we have the graph here. Now to sketch the graph, the domain already have 1 over 2 to infinity. And then the range is always from negative infinity to infinity. Okay, the difference is, we can see that for domain of the exponential, it's always negative infinity to infinity. But for the range of a logarithmic function, it's always from negative infinity to infinity. So it will be the opposite. So let's continue with question C. Y or function fx is equal to log to the base of 3 of 1 minus 4x. So the difference is the function inside this base will be the same. Okay, doesn't matter. So now determine the domain. So the function inside the log should be more than 0. So 1 minus 4x is more than 0. So x should be less than 1 over 4. So if x less than 1 over 4, 1 over 4. So graph here. So it's from negative infinity up to 1 over 4. So the domain is from negative infinity to 1 over 4. 1 over 4 is not included. And then x-intercept. So when y equal to 0, log base 3 of 1 minus 4x is equal to 0. So 1 minus 4x is equal to 3 to the power of 0, which is equal to 1. So for x is equal to 0, so x is equal to 0. So we have point of 0, 0. Okay, now for when y approach to y, what is y when x approach to the endpoint of domain? So when y approach to when x approach to negative infinity, y is approach to natural log base 3 of 1 minus 4 of negative infinity. So negative is positive. So plus 4 infinity is infinity. So 1 plus infinity is infinity. Log infinity is infinity. And then when x approach to 1 over 4, so log base 3 of 1 plus 1 minus 4 of 1 over 4. So 4, so 1 minus 1 is 0. So log base 3 of 0 is negative infinity. Never mind any value of base because it's a 0. So it will be approaching to negative infinity. Okay, now we have the 2 points for the endpoint. Okay, now to sketch the graph, we just have to plot lah. Where if we have point, first of all, draw the asymptote. So here we have 1 over 4 as the asymptote. And then it will cross at 0, 0. So we have point 0, 0. And then the graph when x approach to negative infinity is going to infinity. So going left and up. And then here it's going to 1 over 4. It's going negative infinity. So going down. So it should be this bottom. And then it must be before 1 over 4. Why? Because the domain is up to 1 over 4. 1 over 4 is not included. Also, it will be on the left side of 1 over 4. So connect these 3 points. So we have the graph. Now to find the domain, we have already, first step is to find the domain. And then the range is always from negative infinity to infinity. Okay. Lastly, for question D. Y is equal to negative of log base 10 of 2x plus 1. So, determine the domain. It always, everything inside the log is more than 0. So, 2x plus 1 is more than 0. So, x should be more than negative 1 over 2. So, the domain is starting from negative 1 over 2 up to infinity. Because it's going to the right. So, it should be to the infinity. And then, x intercept when y equal to 0, negative log of 2x plus 1 is equal to 0. So negative is gone. So log 2x plus 1 equal to 0. So base 10 to the power of 0 is equal to 1. So 2x plus 1 is equal to 1. So x is equal to 0. So the intercept is 0, 0. And then determine the value of y when x approach the endpoint of the domain. So when x approach to negative 1 over 2, y is approach to negative of log base 10 of 2 multiply 1 negative 1 over 2 plus 1. So this one will be 0. So negative of log 0 is negative of negative infinity, which is equal to infinity. Okay, so because we have negative and negative, it will be positive. And then when x approach to infinity, y is approach to negative of log base 10 of 2 infinity plus 1. So this one is infinity. Log infinity is infinity. So negative infinity. So one will be negative, one will be positive lah. Okay. And then we have these 2 points lah. So now to sketch the graph, plot the 3 points. We have asymptote first. So we have the asymptote at negative 1 over 2. X equal to 1 over 2. So we have the vertical line at x equal to negative 1 over 2. And then plot the point 0, 0. And then we have negative 1 over 2 infinity. So to the left, approaching to negative 1 infinity, is going up. Okay. So we have this point. And then when x approach to infinity, y is going down, negative infinity. Okay. So this is the point. Actually, it's not really accurate. So it should be connect the 3 point. My graph also cannot. Let me, yeah, like this. Okay, this is our graph. So this is a bit error here. Sorry for that. So this is our graph. Now to find the domain, it's always, we found already at first step, and the range is always from negative infinity to infinity. Okay, so ignore the blue graph. It should be the purple one. Okay, so we are done with question D. Now, what is the relationship between an exponential and logarithmic function? So given the exponential function equal to fx equal to a at the power of x, then what is the inverse of a to the power of x? So a to the power of f inverse equal to x. So to get f inverse as the subject, so we have to put log on both sides. So what base we should choose? Yeah, base A. So log base A of a to the power of f inverse equal to log base A of x. So f inverse will be the subject, will be the coefficient. So we have f inverse of log base A of a equal to log of a base A of x. So now log AA is equal to 1. So we have the f inverse is actually equal to log base A of x. So actually, this exponential, the inverse is the logarithmic function. The inverse of exponential function is a logarithmic function and vice versa. So what it means by vice versa, if you want to find the inverse of a log function, you will get an exponential function. So the graph of the function of a to the power of x, so we have this graph. So if we want to find the inverse function, means that we have to reflect at y equal to x, right? So this is a graph. This is the graph of a log function. The inverse, and so on. This is the statement. This is the relationship of exponential and logarithmic function. So example 5. Let's see. Given that fx equal to 3 to the power of x minus 1 all over 2 and gx is a log to the base of 3 of 2x plus 1, find g of x. Hence determine f inverse. So f of g, sorry. So f of g, f composite g. So f of g, we replace the g with log base 3 of 2x plus 1. And then what is f? F is 3 to the power of x. So we replace x with log base 3 of 2x plus 1. So it will be 3 to the power of log base 3 of 2x plus 1 minus 1 over 2. So because we have 3 log 3 here, so it will be equivalent to 2x plus 1 minus 1 over 2. So 1 minus 1 and 2x minus 2, 2x divided by 2 is equal to x. So f of gx is equal to x. What it means? It means that the g is actually inverse of f. Right? Because this is comparing to the inverse properties. Okay, so f inverse x is actually the gx itself, means that log of base 3 of 2x plus 1. So this is the relationship between f and g. They are inverse of each other. Sorry, not this one. This f and g are inverse of each other because it's complement the properties of inverse. Means that the f inverse, we can use g as the f inverse lah. That's why we have the answer of f inverse equal to log base 3 of 2x plus 1. So example 6. Given fx is equal to log to the base of 3 of x and gx equal to 3 to the power of x. Without finding the inverse function, show that f and g are inverse of each other. So we can use the properties of inverse function, which is f of f inverse is equal to x. Means that if they are inverse of each other, means that f of g or g of f will be equal to x. So now let us find what is composite of f of g and f of function g. So f of 3 to the power of x, and then we replace the x of the f equal with the 3 to the power of x. So log base 3 of 3x. So this x will be the coefficient. So x of log 3 of 3. So we get x. So means that f of g is equal to x. When comparing to the properties of inverse, we can see that f inverse is equal to gx. Means that gx is the f inverse of f. Okay, so g inverse also is equal to fx. We can show by using g of fx. So g of log base 3 of 3. So 3 of log base 3 of 3 is equal to x. So we can use either of these lah. Okay. So what is the relationship between exponential and logarithmic function? They are inverse of each other, vice versa. Okay, so that's all for this lecture. Next lecture we are going to continue with the the method we learned in lecture 2 and 3, which is to find the composite, to find the inverse, and so on. Okay, so that's all for today. Thank you, class.